Now, in this video, we're going to look at the distance formula between 2 points in the coordinate plane. A coordinate plane is the coordinate system we talked about before. The reason we also call it a plane is because these two lines, horizontal and the vertical line, or you call them x-axis and y-axis, they form a plane. We can determine any points in this plane. So, before we look at the distance formula, I want to review two things we learned before. The first one is called the Pythagorean Theorem. And the Pythagorean Theorem says if we have a right triangle, which means one of the angles is 90 degrees, and we have those two straight sides, A and B, and there's a slant one that we call it hypotenuse, C. And the two straight, the square of the sum of the sum of the squares of the straight sides must be equal to the hypotenuse squared. And so that's the first formula, Pythagorean theorem. The second thing I want to review is one-dimensional. If we have a straight line, what's the distance formula between any 2 points on the line? Let's say we pick 1 here and 5 here. And what is the distance between 1 and 5? Well, how far is it from 1 to 5? As you can see, if you count 1, 2, 3, so you go 1 unit, 2 units, 3 units, and 4 units. But it's technically the same thing. If I put a 0 here, you can do this way. You can first find how far is it from 0 to 5. It's going to be the same as the number, because that goes, this 5 means it's the distance from 0 is 5. And then you subtract this distance, because 1 means the distance from 0 is 1. So in order to find the distance from 1 to 5, so from here all the way to there, we can find the distance from 0 for both numbers, which are the same as each number. So we can do from here to here, 5, minus from here to here. That gives us the distance from 1 to 5. You can look at, it's more like a geometry question. Say you have a line segment which is 5 units, and you cut 1 unit off, and what's left? It's 5 minus 1, which equals 4. And that segment left corresponds to the distance between 1 and 5. So for one-dimensional distance formula, it's going to be the bigger number, so I'm going to just call it x, the large number, minus the smaller number. And so in this case, it's 5 minus 1. It always works, even if it's a negative number. Say, suppose we have a negative instead of positive 1. What if we have a negative 1? And it will still work. We take the large number 5 minus the smaller number negative 1. So we have minus minus, that gives us we do the subtraction rule, keep, change, change. That gives us a 6. And if you count, it is really 6 units from here, negative 1 to 5. 1, 2, 3, 4, 5, 6. Because when you subtract a negative number, it's more like adding the opposite of this. So it's like adding from this 5 units plus that 1 unit. That gives a total of 6 units. So this formula works on any 2 positive numbers, 1 positive, 1 negative, or 2 negatives. That's a one-dimensional distance formula. And similarly, even if it's we can change the line to a vertical line instead of horizontal one, and it will still work. Say we have a point here, 1, a point 5, a point down here, 1, and the distance between them will still be 5 minus 1. We're just rotating the horizontal line to a vertical line. The distance formula doesn't change. But for vertical line, usually we call it y, so we can take the larger y value, subtract the smaller y value, and that will give us the distance formula. And so, for example, if I ask you what's the distance between let's say 3 here and negative 2 here, And you can just take the larger number 3 minus the smaller number -2 and do keep change. That gives us a distance 5. So the distance between 3 and -2 will be 5. Okay, so these two are formulas for the distance between 2 points in a straight line. Now let's go back to the topic. We want to look at 2 points in the coordinate planes, which means you have a point in this plane, not necessarily on the straight line anymore. So for example, we may have, let me draw a big one so we can see better. So suppose we have this y-axis and we have x-axis, and we may have a point right here and another point right there. So how do we find the distance? Say this one is may not be proportional, so let's make this one 1, 2, and this point let's make it 4 and let's say 7. So what's the distance? What we want to find out is the distance from 1, 2, this point 1, 2, to that point 4, 7. And because notice that they're not falling on the straight line, horizontal line or vertical line, we can't just subtract the numbers anymore. But what we can do is that the idea is very unique, very creative. So what we're going to do is we're going to create a vertical line and create a horizontal line. So this on this horizontal line, we will be able to use the formula, one-dimensional distance formula. And on this vertical line, we will also be able to use the one-dimensional distance formula. And so we can find this distance and that distance. And notice this is a straight angle, 90-degree angle. So that forms a right triangle. So this is a right triangle right here. And so if we call this A and that B, and you should be able to find the distance C right here. That's what we're looking for, C. So we're not going to find the C directly. We first find the A and the B by using one-dimensional distance formula. And we can apply Pythagorean theorem to find that C there. So in this case, for example, how do we find A? These two straight distances, horizontal distance. And notice that this number, if you go down, that is 1. So this line segment is the same as, use a different color. So this line segment right here is the same, is equal to that line segment. They have the same length. So to find that, I can just find the distance from 1 to 4. From the previous formula, we know we just do 4 minus 1, which gives us 3. So A is equal to 3. And similarly for B, to find that line segment B there, I can just switch then. So this line segment is equivalent to that one. They have the same length. So to find that B, we can just find the distance from 2 to 7 by using the one-dimensional distance formula. So we'll do 7 minus 2, that gives us 5. So that B is equal to 5 there. Now we can go back to the Pythagorean theorem. So we have this triangle, a right triangle, and we can put it down here. So that's 3. A is 3. B is 5. So how do we solve for C? Now we plug the numbers back into the Pythagorean theorem. Pythagorean theorem says A squared plus B squared equals C squared, which tells us 3 squared, replace A with 3, replace B with 5. And replace, we don't have a number for C, so we're going to keep it. And we can simplify that. 3 squared is 9 plus 5 squared, 25 equals C squared, or 34 equals C squared. And we learned radical numbers. In order to find the C's, we can take square root both sides. Because C means distance, it cannot be negative. So we got C equals square root of 34. So that will represent the distance of this red line segment, square root of 34. And we're going to summarize the formula from here. So in general, if I call this point x1, instead of, it doesn't have to be 1, 2, 4, 7, they could be any number. So this is x1 and x2. So that makes this x1, I'm sorry, x1, y1, and this one number is x2, y2. So x1 corresponds to that one here, just like 1 corresponds to that 1 on the x-axis. So x2 was 4, but now it's x2. And y1 was 2, but now it's, I'm changing to, it doesn't have to be 2, it could be any number. I use y1 to represent it. This 7, I use y2 to represent it, could be anything. So if you look how we got this a here, we're taking 4 minus 1. In this case, it's x2 minus x1. So a is going to be equal to x2 minus x1 in this triangle, x2 minus x1 in general. Similarly, we did a 7 minus 2, but now it's y2 minus y1 instead of 7 minus 2. So in general, when we do y2 minus y1, that gives us this b. So when you plug everything in here, we're not plugging in 3 and 5, we're plugging x2 minus x1 for a. For b, we're plugging y2 minus y1 for b. And c, again, remains unknown. And to solve for c, we take square root both sides. The square root will cancel that square, that gives us c. So this line segment c here is equal to that formula. So let me write it clearly. C equals square root of x2 minus x1 squared plus y2 minus y1 squared. So with this formula, we can find the distance between any 2 points. So let's look at an example. Suppose I want to find the distance between 1, negative 2, and 3, negative 4. First, let's mark the, remember the first point, 1, 2, first point. First number we always use x. Second number we use y, we call it y. Because we have 2 points, that's why we name x1, y1. This is x2, y2. So similarly, we can name this one x1, this is y1. First number x, second number y, but this is the first point. I use subscript 1, but the second one we use subscript 2 to distinguish between them. So now we can plug numbers into this distance formula here. So c equals x2 is 3 minus x1 is 1 squared plus y2 is negative 4 minus y1 is negative 2. So there will be another minus sign. So this minus comes from the formula. This minus comes from y1. And now we simplify this. So get 2 squared, 3 minus 1, 2 squared is 4. And to do negative 4 minus negative 2, we do keep, change. That gives us negative 2 squared, which is also 4. It's just a coincidence. So we add them to get square root of 8, which can be reduced to 2 square root of 2. This is a problem we did before, to how to simplify radicals. We can look at another example. First, we mark them down so it will be easier for us to plug into the formula. So that's x1. Again, first number is x, second number is y. First number x, second number y. But because we have 2 pairs, so that's called the first pair x1, y1, second pair x2, y2. Now we plug them into the formula to find the distance between them. X2 minus x1, so x2 is 2. X1 is negative 5 plus y2 0 minus x1 is negative 1. So be careful, you will have 2 minus signs because this minus comes from the formula. The second minus, this minus comes from the number itself. So we simplify that. We do keep, change. 2 plus 5, 7. 7 squared is 49. And keep, change. 0 plus 1 is 1. 1 squared is 1. So we got square root of 50, which can be simplified to 5 square root 2.